All right, so this is picking up on some detail in the sense that we didn't really have time to discuss in the first part of this webinar series. And what I'm going to do is cover some of these points, which are details about getting the paper presented in the best possible way, and having it, easily understood by the reviewers and the editors and the readers at the end of the day. The first point there about getting the story clear picks up on a slide from the previous webinar. So hopefully people have either looked at that or can go back, and maybe this will prompt you to go back and have a look at this if you want to remind yourself what we discussed there. So this slide was in the previous webinar, and I want to pick up on one key point there about the story, which is this highlighted in red there is key data. So every paper tells a story, and you've got to figure out what that story is, following those dot points about what's new, why is it important, what data do you have that is really important in demonstrating that point, and what does it all mean, what are the outcomes. And then you should be able to write down an abstract. And we had in the previous webinar, we had a slide that sort of detailed the basic structure of an abstract. And the key idea in all of this is if you can't write that abstract, having given this a bit of thought, you're probably not ready to write the paper, so don't start. Get the abstract ready first. If need be, continue to discuss it with your supervisor and your co-workers. So bat this abstract around until everybody's sort of clear on the story and agrees on the story, and then you can start. But along the way there, you're going to identify this key data. And this webinar is very much about figuring out how to present your data in the most impactful way, having identified what the key data is. So the key data, of course, so going on to the next slide, the key data is the information that should be in the main paper. And everything else, and the emphasis on everything, because it can be a lot of stuff, should be in supplementary. Now, the trends here are such that supplementary information is becoming more and more voluminous, and there's no problem with that, except that it just makes more and more work for everybody when they're preparing a paper. So I'll come back to that point at the end. So the expectation in 2019 is that there will be substantial background data presented to justify your the accuracy and appropriateness of your measurements, and to support in terms of control experiments and so on, to support the key data, which is in the main paper. So if you've already decided on the previous slide what the key data is, and don't overdo the key data in the main paper, so don't distract the reader from the main points by providing extra information that isn't really needed there, but is valuable nonetheless in supplementary. So everything else goes into supplementary. That's the way to look at it. That supplementary is a big database of nicely presented stuff that convinces everybody that the work is well done and well supported in terms of control experiments and calibrations and so on. Okay. Along the way there, it sometimes becomes either necessary or advisable to put a bit of discussion into supplementary. There's no harm in that. If there's data that you want to discuss, and I think there's a number of times recently that we've put fairly detailed infrared or NMR discussion into supplementary under the data presentation, because in the end, there's often, while you want to present a detailed description of spectra like that, you don't necessarily want more than one or two pieces of key trend or key changes for the main discussion. So it's totally okay to put that kind of data analysis and discussion into supplementary if that's the best way for the paper. And just to put that in perspective, if you look through some high impact journals today, recently published, and look at the supporting information, you can find as much as 50 pages. I think we've had one recently which had a lot of crystal structures in it that was upwards of 100 pages of supplementary information. Now that isn't unusual, it's not a problem, but well, there are some problems. So the next 2 points are about making sure that you kind of organize this properly. First of all, if you've got a lot of supplementary information, remember that the journals don't currently hyperlink directly from your reference to a figure S12, supplementary 12, directly from the paper to that supplementary, because the two documents aren't necessarily linked as such. So it's very hard for the reader, and worse, the reviewer, to find necessarily the key figure that you're talking about, figure S12 referenced in the paper, amongst this huge pile of 50-page long document. So a table of contents then becomes absolutely necessary at the beginning of the supplementary. And it's very wise to link each item, each figure should be listed in the table of contents in each table and so on. And each of those headings should be linked to the point in the document. Word can do that for you, a very simple way later in the document. So it's easy for the referee to go straight to the table of contents, click on figure S12 and go immediately therefore to that part. If you don't do that, you will end up irritating referees and readers very quickly, and they'll just give up. The other problem that comes out of this is that there's a lot of work in presenting all of this information neatly and properly and appropriately. And my advice is that whenever you are working up day-to-day data into graphs of just about anything, or tables, or even schemes of various sorts, make them supplementary ready. In other words, make them so that when you've finally put this into a PowerPoint to show in any presentation, somebody, yeah, that it's already formatted. The fonts are the right size, and everything about it is literally ready to be used, so that you don't have to go back and redo things. It's very wise just within yourself, if not within a group, to have a standard font that you believe is going to work for you in your papers and your thesis and so on. And I know at least of one very big group where the supervisor absolutely mandates that all figures and presentations be prepared with a particular font and size, etc. Everything about, so that everything is paper ready, supplementary ready. So look at it that way. It's all designed to save you time. And if you ever hear anybody commenting on your figures that, oh, that font's a bit small, then you haven't got it right yet, and keep that in mind. I've rarely heard anybody say on a presentation the fonts were too big, and data points and lines and so on. Okay, let's go on then to impactful use of graphics and figures. I think we're all becoming more and more visual people as opposed to written word people. And that means that your story, go back to that story at the beginning of our discussion here, the story needs to play out, or be to be played out by you almost as a storyboard within the graphics and figures and schemes that are part of the paper. Many of us will look quickly to the figures. If it's a field that we think we know mostly about, we'll look quickly to the figures to see what's new here. And the text is only something that you look at later once you're convinced that it's worth doing so. And I think that's a very reasonable way of approaching a paper. But it means we have to present our papers in that way, that the figures must be thoughtfully done in order to present all the key data in a very accessible way. And that means making sure that you put the information into those figures in a way that, for example, in the one that I'm showing there, which I think is a reasonably good example, I think most people recognize in the chemistry materials area an NMR spectrum, for example. So you can immediately sort of think what that is. You don't need too much explanation, and you can glance at it and get an idea. So that's the idea. So now, also very common, and where things can go wrong, is that people are now tending to use, I should say, the space that's available for figures. And sometimes figure numbers are limited by the journal and this may be true for this particular journal here, that there's a limit on the number of display pieces, they call it. And these authors have decided to squeeze 6 actual figures into 1. Okay, in fact 7, because there's an inset to the bottom left one. All okay, very common. Again, just don't overdo it, and just don't present so much information that in the end maybe doesn't need to be presented and should be in supplementary. So there's a limit to how far this can go before it's an overload. Before I go on to an example in which is, I think this one is a good example. The next slide is an example of one that's not so good. Let me just go back to the middle point there, which is that graphics, graphical processes and concepts are very, very good. So I think every paper, it's almost like what we maybe started off some years ago, putting into table of contents graphics are becoming an important part of a paper to tell the story of our concept or our hypothesis, and see if you can put the hypothesis of your paper into a scheme or a graphic that illustrates it. Remember, it's only a speculation. We'll come back to that point in the paper. Usually, but it's still very useful, so the reader has sort of a visual impression of what you're thinking about, much easier than trying to do it in words. So on this slide, I think we have an example of overuse. We have 6 items in the single figure. 2 of those. Yes, only two of those have further insets inside the figure. So effectively, there's 8 display items here. On the screen, as I'm looking at the moment, I can just read the fonts on top left, figure A, as in the main fonts, but the inset I can't read, and I'm going to have to somehow or other blow that up. I won't try and do it here, I might not succeed, in order to read that, and that's maybe not desirable. So this has gotten the fonting here isn't really desirable. Figure, there's too much squeezed into 2E to make it truly readable, I think. And really F is totally confusing, if not, and D, again, everything's too small to read. So there's lots of problems with that figure. If you go around it, you see there's issues all over the place. So I think the authors in this case just went too far. They tried too hard to squeeze it all in, and really some of this could have been put into the supplementary, I think. Okay, so the message here is definitely work hard on your graphics. I think that's one of the reasons that ACES has had a graphics competition for a long time, is because we recognize just how important these are, and in some cases how the skill level of many of us, I'll include myself in this, the skill level isn't so great, and the challenge is for all of us is to upskill in drawing graphics and so on. So there's basically nothing in this figure here that I would think that, or I would like to think that all of you could do that without too much trouble. And if I go back to the previous one, I think same's true here, and I'd like to think you could all do that 3-dimensional plot somehow or other, etc. All right, so constantly looking for ways of upskilling your graphic presentation skills. It's gonna get to be a bigger matter, not a smaller matter. Here's some tips and tricks, some things to do and not to do, with our goal being to make this whole paper readable, with all that lovely information in the supplementary to back it up. And what we don't want, as you see in the little graphic there, is somebody basically to fall asleep. I do recall some years ago working with a paper written by a colleague, I won't say who, and having sent it off to another colleague overseas who sat on it for a very long time, and we were anxious to get his comments back so we could get the paper done. And he wrote back after several nags from me and said, "Doug, I read to about halfway through, but at that point I lost the will to live." Now, what he meant by that was that he just couldn't maintain interest in the paper, even himself as an author, to get beyond a certain point, because it was too densely written, was in the fault in this paper, right? And I had to go back and I basically cut probably a third of the paper out into supplementary to make it more easily followable. Okay, So here are some tips and tricks. Things to do, use subheadings. Long paragraphs and long numbers of paragraphs meandering from one point to the next is very easy for the reader to start to lose the point. And that's never good. So the strategy here is to use subheadings. Later on, you might decide you don't need them, but subheadings are actually a very good strategy to help you write the paper in a logical fashion. So you can frame up a paper with the subheadings in place first, write beneath them, and then later you might decide, or one of your co-authors that may say, hey, I actually don't need these, but they rarely do any harm. Use them. Use logical linking words within a paragraph. I find if you want to build a chain of logic, it's good to link one sentence to the previous one with a logical word, which says there's a logical result here. These are words like hence, thus, however, and there. For, oh, we lost that. That's hidden behind the graphic. Therefore is what it should be. So these are words that help the reader understand what it is that the next sentence means in respect to the previous one. And there's a mathematical language that each of these actually means. It's very important to be honest about the background literature. There's, I think there's a growing trend to be a little bit selective, and there's nothing more guaranteed to get a paper rejected if the referee comes back and says, well, you know, this paper doesn't seem to recognize XYZ paper, which, you know, has done, et cetera, et cetera. Those are extremely embarrassing and almost guaranteed to get you a rejected comment. So be fair and honest about that. Things to not do for reasons of losing the will to live of the reader or not get them irritated. So first of all, many of us deal with long chemical names or descriptions of materials. And if those, you need to put those in the paper once somewhere, often in the experimental or in the introduction, and then maybe put an abbreviation, but try not to repeat big long names of chemicals and compounds, because reading those repetitively, it's extremely hard to keep reading them, especially if there's more than one of them, so you're never very sure which one it is that you've just read. So very important to reduce that to an abbreviation. And to use abbreviations that are relatively standard in the field. Don't go making up new abbreviations unless you're sure that, that you have the right to, so to speak. But you do need to use abbreviations to make it readable. Don't use hype words. Maybe it's just me, but I find these extremely irritating because it tells me that the writer is more interested in selling their work than they are in describing it honestly. So, you know, most of us have read papers where there's words like ultra and massive and extraordinary, and there's a few other where you're thinking, well, it's not that ultra, and it's not really that extraordinary. So unless you've got something that is genuinely, completely unexpected, I don't think those words are useful. The journals are not very good at sifting these out, but I can tell you that journal editors basically don't like them either. But there's many referees who use them, and therefore they prepared to let them go through themselves. Or to put that another way, there's quite a lot of bad practice in the world of published science, which is propagated by the people who are doing, and as the reviewers are themselves got these what I would call bad habits. That doesn't mean to say that we should all have these bad habits. So you just have to have your own views and then stick to them in terms of what you think is an appropriate style. Another thing that's quite common, so you must be able to see it and then not do it yourself, which is mixing up your hypothesis or your concept and then drawing a diagram of it, which is always good, like I've said, but then thinking that it's a fact. And then describing everything as if to say, this must be true because of my concept. Actually, it's the other way around. Your concept is a hypothesis, and it awaits being proven, right? So the data is the evidence, and that hopefully is at least consistent with your concept, your hypothesis. It rarely can prove it. That's just life, but it can be all consistent with. Is a very good phrase to use, consistent with. But to write it as if to say, here's my concept, it must be true, and this data is consistent with it, but other data that's not consistent with it must be wrong, or anything along those lines is very incorrect from a logical point of view. So be careful about how you structure that. And of course, the last thing to avoid always, and it's always going to be something we have to remind each other of, is don't plagiarize. This is a constant issue. I even came across a rather significant example in a grant application that I was reviewing 3 or 4 months ago. And I actually don't know the outcome, but I suspect it wasn't good for the applicant to have plagiarized so obviously. So plagiarism is never good, and it's a matter of understanding the problem and never ever, don't ever get into the habit that could even accidentally lead to plagiarism. Okay, and if we need to talk about that anymore, I'm sort of happy to do so. Okay, last thing is to look through this editing example. And what I'm going to do so I can do the editing on screen is break out here. Hang on, just bear with me. I'll stop sharing, and I will instead go to this. Hang on. So I'm going to go to the Word version of this, and we'll do this. I think we should be able to do this together online, right? Okay, so I think with something like this, you can work through something like this with 3 different hats on, 3 different kinds of editing. The first that I'm going to do is what I would call a grammar, spelling, general ambiguity, so words that don't seem to make any sense. That's the kind of thing that an English editor can do too. And if I'm looking at something that isn't sort of, is at a rough draft sort of stage, I will often get Kate, or who's helps us down here a lot, to do the English editing and some of the structural editing first, because I find that if it's full of little mistakes, as this is, I find it actually very hard to read and be sure of what it is I'm reading. So it creates an ambiguity problem, right? So ambiguity is one of the things we try to sort out at this stage. The next pass through can be what I would call a structural look at it. Once you've sorted out the language so you can understand what each sentence actually means, the question is, are all the sentences in the right place? So that's structure, and do they logically flow? And then the last thing to do is to go through and do what I would call a science edit, which is the science being presented all correct, and is the information that's needed all present and correct, right? So three different points of view. Let's do this together. So let's do the first. And if we were working all in one place, I would probably get people to shout out suggestions. Yeah, I might do that in a minute, but let me whip through and show you quickly, for the sake of time, some of the quick fixes that I would do. All right. And by the way, before we start on the grammar, notice that there's only one blue underline down here in this paragraph. So Word Grammar Checker has only found one problem. Let's see how good Word Grammar Checker is. All right, well, there's a grammar problem right here. So were is a plural verb. So we're talking about, if we want to stick with were, we must be talking about more than one samples. So that's, hang on, I will put reviewing. No, that's not what I want to do. What I want to do, I want to put on track changes. That's it. So that has to be plural samples because of the verb we've used there. We could have changed that to a singular one, but that's the simplest fix there. The samples were prepared by microwaving. Do we think microwaving is a word? Is that a proper word? If it is, it's a little informal. So maybe I'm being a little bit picky here, but it might be better to say by being treated in a microwave, laboratory microwave, or something a little bit more than that's a bit informal, but we might leave it for the moment. For 60 minutes, followed by drying overnight in vacuum oven. That's missing an article. Before vacuum oven, we want to know sort of which vacuum oven it was. We haven't described a vacuum oven anywhere else here, so it can't be the vacuum oven. It needs to be a, whoops, wrong place. It needs to be a vacuum oven. So English, much to the annoyance of a lot of non-native English speakers, English is full of these articles that, these are the and a type words that indicate this and there and so on. And these tell us a bit more information about the thing that we're about to talk about. And if you get used to using these, every time somebody fixes an article, maybe ask them why they fixed that, and they'll try to explain. In this case, it's describing the vacuum oven, but it's saying it is not any particular one, it's any one that happens to be in our lab effectively. Okay, let's press on. FTIR and UV spectra are then, okay, we have a problem here. The problem is that previously we were working in the past tense. You typically do write an experimental section in the past tense. So that would be normal. Here we switch to the present tense. That would be unusual to write it this way. This is written more like a set of instructions. If you're writing a set of instructions for a third-year student in the laboratory, you might write it in the present tense. So there's nothing wrong with writing in the present tense. In some cases, normally this sort of section would be past tense, but most important of all, stick to one tense. We're going to have a third tense come up here, and mixing tenses up in a paragraph is usually wrong, right? So try to understand tenses, past and present and future, and then stick to one of them. In this case, would be were, then obtained on the dry samples. Elemental analysis reveals NC mole ratio of that number. That's probably okay. This ultra high N content. Now, you know, really, this is, I think, is just unnecessary, right? You could, so step number one, let's get rid of the ridiculous claim. This high N content, okay, maybe if the previous introduction to this paper has made it very clear that a number like 0.35, in other words, a mole ratio of nearly 1/3 of N in a carbon material, as an example, was high, that was our goal, then that's okay. But the ultra high, I think, just is rarely necessary, and I think it's better to just be a little moderate as opposed to be constantly trying to claim the best ever. Arises from metal in orbital overlap during the microwave process. That's probably okay. Cobalt content was determined. Now the word is warning us there's a problem here. That's not the right ending for the word determine in the past tense. It would be was determined. So something has to be fixed there. Was determined by digesting samples and then measurement of concentration by ICP-MS using standard additions method. Many of you probably wouldn't have hesitated the way I did, but I really think in the very best English that would have the samples. Why the? Is because we do have certain samples in mind. We have a particular set of samples, not any old ones, but the samples that have been made according to the method of the previous 2 or 3 sentences. So it's the samples and that's what that word that means. It's describing them in particular. And likewise, when we were describing standard additions method, I think we want to describe the standard additions method, or alternatively, if you want to make it a little broader, it could be a standard additions method. That the in this case basically requires somewhere else, probably in the supplementary, that you describe in more detail what you actually did for the standard additions and probably show the plot. So this phrase here is begging for a lot more information. We'll come back to that. The microwave also used ionic liquid component NTF2. It's probably okay grammar-wise. For CVs, the sample had been coated with AL foil and cycled at 50 millivolts per second. Had been is yet another past tense, but it's a different past tense. So remembering we're trying to stick to one, and had been is an even more historically ancient past tense than were. So I think we started off with were at the beginning. So we want to stick to that here. The samples were coated with AO foil and cycled at 50 millivolts per second. Okay, I'm going to come back to that in a minute because I think that that's ambiguous. As it was written before I changed it, it seemed that this bit was part of the preparation of the samples, as was the coating, in preparation for the CV. So let's look at that again. It reads as if for CVs, the sample, something was done to the samples, and it rather seems that this is part of that thing that was done in preparation for the CVs. But many of us will know that probably that's not what it meant, because it doesn't, you know, if you know this kind of work, you're knowing probably it's actually trying to say that the CVs were done at 50 millivolts per second. So what we have here is a sentence that is ambiguous. We don't really know what it means. And it's hard to fix this without actually going right back to the person who did the work and saying, what do you actually mean? So Kate would probably have to discuss with all of us down here to fix this. My suspicion is that, so remember, ambiguousness is terrible. So for CVs, the sample were coated. Well, here's another problem. Let's fix this one first. Coated with aluminium foil. That's not right, is it? Coated onto aluminium foil. I don't think with ever made sense. So I think it might be simplest to put a full stop there and then say CVs. This is not very nice English, but CVs were cycled at 50 millivolts per second. That clearly breaks those two facts up into two, and we're giving the information about the cycle rate of the cyclical telemetry. So the point of that sentence, of that issue, was that there was a terrible ambiguity about what the sentence was actually saying. All right, that was mostly grammar, and you can see that we had to fix, well, not every sentence, but quite a few sentences there. Let's go through now and look at it from a structure point of view. We're going to look at each sentence, which now in itself is readable and hopefully makes sense. Each one makes sense. The question is, does each sentence belong in a nice logical flow here, or is there something wrong, right? So let's just quickly skim through this. We're talking about how we made the sample. We're talking about the next thing we did, which is the spec, and then elemental analysis. But what's this business? This is an experimental section where we're just giving details of what we did. Suddenly we are talking about what we actually think is going on, and it doesn't really remotely belong here. At best, it belongs way deep in the discussion section, much later on, once we started to discuss the results in more detail. So this sentence just doesn't belong here at all. And I'm going to put sort of, this would be later in discussion, we might use this sentence. So we're going to pluck it out of there and park it for later use. Okay. Now remember, the little trap that the writer fell into here was wanting to. This apparently was an exciting result, and the writer wanted to quickly explain what was going on because it was so exciting. Wrong. Give the result. Give all the data. Let the case build up, factual case build up, and then start talking about what it might mean. Okay, so then we go on. Think that's probably okay. But here we seem to be talking about a detail of the microwave stage. But the microwaving was only mentioned in the first sentence. So this sentence seems to be out of place. And that's easy to do when a paragraph like this gets written, often in stages, and things get inserted and so on. So it's not a big crime, but it's terrible. It's terribly distracting ultimately to the reader when something like this is way out of place. This needs to be probably almost the first sentence, so it needs to be up here. No, it doesn't quite make sense. We need to provide more information about effectively what the mixture that was in the microwave was, but it certainly belongs up in the discussion of the microwaving. then the whole paragraph flows from beginning to end. It starts with the preparation of the samples and it finishes up with some electrochemistry. All right, so that's structural analysis, right? Sentences are probably fine, but some of them are in the wrong place. And remember, that's a very, very distracting thing to leave there. Okay, last skim through. Finally, then we're on to the science. So up until this point, we were just straightening it all out. Now we're on to the science. Is the science sound? Is all the scientific information that needs to be there present, right? Especially in experimental. Now we've already identified that this seems to be missing information. We give some information, but we don't give all the information. So if we're going to talk about one of the components, we need to talk about the rest and just give the full formulation. So sitting there like that, this sentence isn't nearly enough. It needs more. Okay, microwaving, more detail needed in an experimental section. What was the power of the microwave? What was the volume of the sample that was in the microwave? If we're able to, as some can we report the temperature that the sample reached? So an experimental section that is light on detail is actually very poor and would probably get you rejected, or certainly going to raise lots of flags with a reviewer. If it becomes too voluminous, you can say further details are presented in the supplementary and write a more detailed section supplementary. Because of the availability of supplementary, full detail is required. And don't be distracted by a paper that's come from 5 years ago. That's a different era, right? In 2019, you need to give all this detail because you can. Okay. Vacuum oven also. What's this annoying thing? How do I get rid of that? Don't know what I did, but anyway. There we go. Vacuum oven. Again, not enough detail. We want to know temperature and vacuum, okay, and time. Or drying overnight, probably okay, but we really want to know about the temperature. We would like to know about the instruments used here and their resolution. Maybe a bit more information about what mode was used. Was it an ATR, FTIR? Was it a diffuse reflectance UV-Vis? So at the moment, this is light on in terms of detail. If there's further detail on the supplementary, that's fine, but we've got to say so. Elemental analysis, definitely going to need to report the full detail of that analysis in the supplementary. So we want to be saying, there's frequently here, there's a need for, would be something like C table S4, S3, where the full detail is presented, right? So the reader who wants to see the full analysis can see it. Reveals NC mole ratio of 0.3512. Probably overstated in terms of significant figures. Huge issue in lots of papers, and they're all, at least you could say, poorly presented if they're overdoing the significant figures, right? So elemental analysis is usually good to maybe only 3 significant figures, and by the time you divide one of them by the other, you may even lose a further significant figure. So I would probably accept that but I would want to see the actual data that was used to calculate that number. But my guess is the 2 was never significant. And as soon as you give too many significant figures in a paper, you're basically saying that you're to the reader, or especially the reviewer, that you're a bit of a thoughtless scientist, that you don't really think hard about what the meaningfulness of your measurements are. None of us wants that, right? So be careful about that. And if you don't, every time you hear somebody picking up on your significant figures, if you do, learn about it, ask them about it, get it explained to you where your mistake was, right? Okay, where are we? Cobalt content determined by digesting the samples. And then, again, all of this needs more detail. What were the samples digested in? There's usually an acid mixture that's used. We need to see the standard additions plot, so there's much more information needed there, and probably in supplementary. Oops, I think also here, now that we've straightened that out, but again, that coating is probably, there's more detail there that again is not needed. So that's the same message all the way through here. And then finally, now that we've separated out this, we would now realize that there's a lot of electrochemistry information, reference electrodes, counter electrodes, electrolyte. So there's a lot of detail about the cyclovoltammetry that's not been put in here. We've given one piece of information, but we haven't given it all. So that's a bit of a warning. Okay, so remember that final step was all just assessing just whether the information that's being presented, in this case experimental, is the right information. And then figuring out how to present it. The same kind of a thoughtful look through results and discussion. We'll just check whether everything's being presented in adequate detail, not too much, but adequate detail. So remember those three then approaches to editing for impact. So first of all, get the English and the grammar sorted out and any ambiguities. The second is look at the structure. So that's usually whole sentences that maybe aren't in the right place. And then the third is the science, making sure that it's all properly presented in various ways. All right, that's it from me. Now, do we have any questions or discussion?
I actually have one question.
Yes.
In the sentence that they give the mole ratio nitrogen carbon,
yeah,
is it actually needed? Because it's giving you an information but it's doing nothing with it. So I don't think that maybe that would be an experimental piece of information. It will go more in the discussion maybe.
Good point. Absolutely. Sometimes you put what you might call basic characterization information into a paragraph like this because it's not all that important later on. But this particular, remembering how we started off with this being described as ultra high, this particular result in this paragraph sounds like it's very important in the whole context of the paper. And if that's true, it probably shouldn't be here. It should be at the beginning or somewhere relatively early in the results and discussion because it's an important result. Right, so you're quite right. If it's an important result, which this is, it doesn't belong here. Yep. Any other thoughts like that?
And also the first sentence that doesn't make any sense for me. Like microwave also used ionic liquid component with EMI, TFSI. Yeah. It doesn't follow up with the other part.
Yeah, I totally agree.
So what's the point of putting that one there?
Yeah, I think we moved that there. It didn't seem to belong where it was, but it still doesn't really. It's not sorted out yet, so to speak. The problem with this sentence is it's giving a bit of information, but it's not giving enough information to make sense. So I think we all agree this sentence either needs to be deleted, but probably what it's reminding is that we haven't given enough information, because this is the only place it's going to turn up probably, about the details of how this microwaving mixture, if you like, preparation stage was carried out. What was the mixture that was used? So it's I'm leaving it there as a warning that we probably need a fair bit more detail, another sentence or two, even before this one, describing how the microwaving was done. Right, but certainly you're right. At the moment, sitting there on its own, it doesn't make sense, and it's not nearly adequate. Okay, any other thoughts or comments? Okay, all quiet. I'm not at the moment seeing any chat messages, so hopefully I would see them if there were. All right, I guess we'll leave it there, guys. So hopefully that's been helpful, and as I say, possibly the most important thing to remember about this editing stage are those 3 stages. And if you don't feel comfortable with the English grammar stage yourself, because English is not your mother tongue, that is totally fine. Get somebody to help you do that stage, but do try to learn every time somebody corrects something. I think a good philosophy is try to learn why it's been changed. Most of you are here to learn, and this is an important thing to learn if you see your future either working in an English-speaking country or in publishing in English language journals. You know, in the rest of your career, the better that you can write, the better you will be. So that's just you should have a learning philosophy. Okay.
Sorry to disturb you.
Yep.
But there's one comment made by Carrie in the chat room I found.
Say again, sorry?
There's one comment made by Carrie, I think.
Okay.
In the chat room. Could you please check it?
Could you read that out for me?
Oh, all right. Yeah. In terms of tense, should it say elemental analysis revealed the molar ratio, but it's written as reveals?
Oh, very well done.
Yeah.
I missed that. Yes.
And there's one more comment by Carrie. Also, there should be.
Hang on. Let's take them one at a time.
All right. Yeah.
This is a good one.
Right.
Now, this is where, because you notice that that I skimmed over that and didn't pick up on that. This is where there can be 2 approaches, right? When you are reporting results, and so this is especially if we were to move this, as somebody else pointed out, we really could move this sentence into the beginning of results and discussion. Then it can be appropriate to report results in the present tense, because the result is presumably sort of always present, and the spectrum always reveals certain bands and so on, right? So there's a presumption that the results not only were true, but are true still. So that's present. So to summarize what I just said there is, you can use either if you're reporting results, which this is. However, it's best to try to stick to one only tense. So you could either say elemental analysis revealed, past tense, and then make sure everything else is in the past tense. Or if you want to use the present tense in a results and discussion presentation, then that's okay, in which case this would be okay, right? But it's certainly not okay with this is what we're talking about, sitting here in a paragraph that is all written in the past tense. So if we wanted to leave it here, we would probably just, so it didn't stick out like a sore thumb, we would make it revealed. Good, so well done whoever picked that up. Go on, was there something else picked up?
So also there should be a spice between numbers and their units. For example, they're cycled at 50 millivolt per second. So there should be a spice in there.
Gotcha, yep.
Yeah.
So what we're talking about is that, and quite right. In fact, that's always true. Some journals will have specific instructions about how you present something like that, as opposed to, this style, right? And let's make sure everybody is following what I'm doing. That style. The key thing here is to be consistent. So there's nothing worse than having to go back through a paper and sort all that out, because in some cases, maybe one author has used one style and another has used another style. By and large, this is the correct style so you don't use a slash. Using a slash becomes very unclear if it gets to be a more complicated thing. And some journals will insist on this space, others will be okay with that. But because of this, usually the separate units are separated by a space. And the thing to do there is look carefully at the journal that you're publishing in, and look carefully at the way it's done in that journal, and then follow that for sure. All right, so there's a lot of little traps in that stuff. Good. Anything else?
Sometimes they mention like CVs were cycled at scan rate, like they mention the word scan rate in some paper. In some papers they just mention the figure. So which is the right way? Just either do we have to mention the scan rate or just go with the figure?
Yeah, I think that this is a little informal as it's written. It's a bit too brief. So what you're saying is really better. So I would prefer to build this sentence out quite a bit and say CVs were conducted at can't get rid of that, at a scan rate of that, right? And then I would actually prefer to continue on in this sentence or new sentence with in XXX electrolyte at 22 plus minus, degrees C. You get the point. With a YYY counter electrode and a ZZZ reference electrode. Right? So all of this is important information that you can't skip over. So what we had there was way too light on detail, and the point was it sort of reminded us that there was a whole lot of stuff missing. All right. Okay, any other? These are all good comments. Any other thoughts? No. Okay, I think that's probably a good time to end. That's nearly an hour, so that's going to be a very long session once it's put into a video. But hopefully that's all been useful for you and just giving you some tips as to how to produce a tidy manuscript, at almost first draft stage. Once you've worked on it yourself, if you can iron out all of these wrinkles, then your co-authors and your supervisors will be extremely happy and impressed at what you're doing if you can do all this stuff yourself. So leave that with you, and thanks for joining us today. Thanks, everybody.